Hey everyone, welcome back to the channel. I'm excited you're here for episode 10 of our system design series. Today we're tackling something really special, designing an e-commerce platform from the ground up. Let's start by breaking down an e-commerce platform into its core building blocks. Think of these as the essential organs of your digital marketplace. Each one has a specific job, but they all need to work together seamlessly. First, we have the user service. This handles everything from signups and logins to user profiles. Pretty straightforward, but crucial for personalization and security. The product catalog is your digital storefront, product listings, categories, descriptions, images. This needs to be fast and searchable because if users can't find what they want, they leave. Then comes the inventory service, and this is where things get interesting. This tracks available stock in real time across potentially millions of products. One moment of inaccuracy here, and you're overselling products you don't have. The cart service manages those temporary shopping sessions, items users are considering but haven't committed to yet. Sounds simple, but coordinating between cart contents and actual inventory availability, that's a complex dance. The order service is where intent becomes commitment. It confirms orders and kicks off the entire fulfillment process. This is your single source of truth for what customers have actually purchased. Payment Gateway handles the money flow, integrating with Stripe, PayPal, or whatever payment processor you're using. Security and compliance are absolutely critical here. Finally, the notification service keeps everyone informed, order confirmations, shipping updates, promotional emails. It's the voice of your platform. Now here's where the rubber meets the road. How do all these services actually talk to each other? Because in a distributed system, communication is everything. You've got two main patterns here. First, REST APIs for synchronous communication. When a user wants to add something to their cart, the cart service needs to immediately check with the inventory service. That's a synchronous call. We need an answer right now. But then you have asynchronous communication through message queues, and this is where tools like Kafka and RabbitMQ shine. Think about it. When an order is placed, you don't need the notification service to immediately send an email before the order can be confirmed. That can happen in the background. The key principles here? Loose coupling. Services shouldn't know too much about each other's internal workings. Clear contracts. Every API should have well-defined inputs and outputs. And versioned APIs, because you need to evolve services independently without breaking everything. This isn't just theory. Companies like Netflix have thousands of microservices communicating this way every second. Let me walk you through one of the most critical flows in e-commerce, from cart to checkout. This is where most of your revenue conversion happens, so getting this right is absolutely essential. Step 1. User adds items to the cart service. Seems simple, but behind the scenes, you're validating that these products exist and are available. Step 2. The cart shows real-time product availability. This means constant communication between cart and inventory services. Nobody wants to get to checkout only to find out their item is out of stock. Step 3 is where things get exciting, checkout initiation. When that checkout button is clicked, you need to temporarily lock those items in the inventory service.
Why?
Because in the time it takes to process payment, another customer might try to buy the same item. Then you generate an order in the order service and redirect to the payment gateway. If payment succeeds, you notify all relevant services, send confirmation emails, alert the warehouse for shipping. If payment fails, you immediately release those inventory locks. This flow handles millions of dollars in transactions every day for major retailers. Get it wrong, and you either oversell products or lose legitimate sales. Here's where things get really challenging: inventory consistency. Picture this scenario. You have one iPhone left in stock, but 100 users all add it to their cart at the same time. What happens next? This is the classic distributed systems problem, maintaining consistency across multiple services with concurrent access. The naive approach would let all 100 users proceed to checkout, but then 99 of them would face disappointment. The solution? An inventory reservation system. When items are added to cart, you temporarily lock that inventory. These are time-bound locks, maybe 15 minutes, giving users time to complete their purchase without holding inventory indefinitely. For distributed locking, you'd typically use Redis or Zookeeper. But here's the key insight: you don't always need perfect consistency. Sometimes eventual consistency with compensation mechanisms works better for user experience. Think about it. Would you rather show an item as available and very occasionally have to apologize and refund, or show everything is out of stock until you're 100% certain? Different businesses make different choices here based on their risk tolerance. The order service is the beating heart of your e-commerce platform. It's where shopping intent becomes business commitment, and the design here needs to be bulletproof. Every order goes through a clear life cycle: created when first generated, paid after successful payment, shipped when it leaves the warehouse, and delivered when it reaches the customer. But the real complexity is in managing these state transitions reliably. This is where patterns like state machine or saga pattern become invaluable. They ensure orders can only transition through valid states and handle rollbacks when things go wrong. The order service also needs to handle edge cases that happen in the real world: duplicate payments when users click multiple times, order cancellations after payment but before shipping, and partial stock issues where only some items in an order are available. Remember, every major e-commerce outage you've read about usually traces back to problems in order processing. This service needs to be your most robust, most monitored, most carefully designed component. Payment integration is where technical complexity meets regulatory compliance. You're dealing with real money, which means zero tolerance for errors and strict security requirements. Most platforms integrate with third-party gateways like Stripe, Razorpay, or PayPal rather than handling payments directly. Smart move. Let the experts handle PCI compliance while you focus on your core business. The key here is using webhooks for status updates. Payments are inherently asynchronous. A user clicks pay, gets redirected to the payment processor, completes the transaction, and then gets redirected back. But your system needs to know what happened even if that redirect fails. That's where webhooks come in. The payment gateway will call your system directly to report transaction status. But you need to validate everything: the amount matches your order, the order ID is valid, and the signature proves the webhook is actually from your payment provider. Here's a critical rule: only mark an order as paid after you receive and validate the webhook. Never trust just the redirect from the payment page. Users can manipulate that. Let's talk about some advanced patterns that separate good e-commerce platforms from great ones. CQRS, Command Query Responsibility Segregation, is incredibly powerful here. You separate your read and write models. Order creation might use a normalized database for consistency, but order history queries might use a denormalized view optimized for fast reads. Event sourcing takes this further. Instead of storing current state, you store the sequence of events that led to that state. So instead of order 123 is shipped, you store order created, payment processed, item picked, package shipped. This gives you incredible auditability and the ability to replay state. Circuit breaker and retry logic are essential for reliability. When your payment gateway goes down, you don't want that to crash your entire platform. Circuit breakers detect failures and stop making calls to failing services, while retry logic handles temporary glitches gracefully. These aren't just academic concepts. Netflix, Amazon, and other major platforms rely heavily on these patterns to maintain reliability at scale. Database selection in e-commerce is all about matching the right tool to the specific job. One size definitely does not fit all here. For users, orders, and payments, you want ACID transactions and strong consistency. PostgreSQL or MySQL are perfect. You need to be absolutely certain about financial data and order states. Inventory is fascinating because it needs both speed and persistence. Redis for lightning-fast lookups and temporary locks, backed by SQL for persistent storage and complex queries. Product catalog is where NoSQL shines. MongoDB gives you the flexibility to handle different product types with varying attributes. Electronics have different specs than clothing, and your database should adapt easily. For search functionality, Elasticsearch is the gold standard. When users search for blue running shoes under $100, you need full-text search, filtering, and faceted navigation that SQL databases just can't match efficiently. The key insight? Don't force one database to do everything. Use the right tool for each specific requirement and design your services to abstract these choices from each other. Now, let's talk about production-ready considerations, because a system that works in development but fails under real load isn't worth much. Horizontal scaling is your friend for stateless services like cart, product, and catalog. These can be replicated across multiple instances easily. But services like inventory that manage state need more careful scaling strategies. Rate limiting becomes crucial, especially for payment endpoints. You don't want someone accidentally triggering hundreds of payment attempts and racking up processing fees. Authentication and authorization need to be baked in from day one. JWT tokens or OAuth 2 for API access, with an API gateway managing access control and monitoring all traffic. Here's something many developers miss: idempotency for order and payment APIs. If a user clicks place order twice due to a slow network, you should create only one order, not two. This requires careful design of your API contracts and duplicate detection mechanisms. Security isn't an afterthought in e-commerce. It's a foundational requirement that influences every architectural decision. Let's wrap up with the key insights that will serve you well in both interviews and building real systems. E-commerce platforms represent real-world complexity in distributed systems. Unlike a simple CRUD application, you're dealing with money, inventory, and user expectations for reliability that approach 100%. Asynchronous messaging through tools like Kafka isn't just a nice-to-have. It's essential for building resilient, decoupled systems. When your email service goes down, orders should still process successfully. Always design for partial failures. In distributed systems, failure isn't exceptional, it's normal. Your system needs to handle scenarios where some services are down, some are slow, and some are returning inconsistent data. The microservices pattern gives you independence and scalability, but it also introduces complexity in service coordination, data consistency, and debugging. Make sure the benefits outweigh the costs for your specific use case. Most importantly, think in flows, not just APIs. Understanding how data and control flow through your entire system during critical operations like checkout is more valuable than knowing individual service details. Coming up next is episode 11, and this one's going to be a game changer for many of you. We're covering system design interview strategy, the frameworks, mindset, and live whiteboarding techniques that'll help you ace those interviews at top tech companies. Before you go, I'd love to hear from you in the comments. If you found this video helpful, do give it a like, share it with your friends, and of course don't forget to subscribe to the channel to help us grow. I will see you in the next one. Till then, happy learning.